There is a moment somewhere around the 40th hour of a water fast when something quietly shifts. You have been going along fine, drinking your water, feeling the hunger come and go, and then at some point, maybe after a workout or just waking up from sleep, you notice it. Your sweat smells different. Not terrible, not alarming, just noticeably, unmistakably different from what you know. Like something underneath the surface has changed its chemistry. A lot of people who reach that point assume the worst. They think maybe the body is stressed, maybe the fast has gone on too long, maybe this is a warning sign they should not ignore. So they stop, or they worry, or they search for answers, and end up more confused than when they started. But what if that smell is not a warning at all? What if it is actually the most direct and honest thing your body has communicated to you in a long time? That is exactly what today's video is about. We are going to walk through what is actually happening inside your body during those 40 hours, why the chemistry of your sweat changes the way it does, and what different smells actually mean, because it turns out your body is sending specific readable signals, and you just need the right context to understand them. Before we go any further, a quick note. This content is educational only, not medical advice. Please talk to your doctor before attempting any extended fast, especially if you have existing health conditions. And if you are pregnant breastfeeding, dealing with an eating disorder, have type 1 diabetes, kidney disease, or you are underweight, prolonged fasting is not the right path for you, and nothing in this video should be taken as encouragement to try it. Now let's get into the science. The first thing to understand is that your body does not run on one fuel. It runs on a hierarchy of fuels, and it works through them in a very specific order when food stops coming in. The first fuel is glucose, the sugar your body gets from the food you eat, especially carbohydrates. This is the body's preferred go-to energy source. When you eat regularly, glucose is almost always available, and everything runs on it without much drama. But when you stop eating, the glucose supply cuts off. And here is where most people think the body simply panics and starts breaking down everything it can get. That is not what happens. The body is far more organized than that. Your liver holds a stored form of glucose called glycogen. Think of glycogen like a power bank that your body keeps fully charged at all times for exactly these moments. As long as that power bank has charge left, your body draws from it steadily, and you coast through the early hours of a fast without too much difficulty. Some hunger, maybe some mild tiredness, but the system stays stable. For most people, eating a typical modern diet, that glycogen power bank runs out somewhere between 18 and 24 hours into a fast. The exact timing depends on how much you ate before, how active you have been, and your individual metabolism. But for the majority of people, by the time you hit the 24-hour mark, the liver is running low. This is where the real story begins. Once glycogen is gone, the body has a decision to make. It can either start breaking down muscle for energy, which would be a disaster for survival, or it can tap into the one fuel reserve that is actually built for long-term situations like this: body fat. The body chooses fat, and it does this through a process where the liver starts converting fat into a different type of fuel called ketones, pronounced ketones. Ketones are essentially a cleaner, more efficient energy source that the brain and muscles can use just as well as glucose, sometimes even better. This is not a malfunction. This is a design feature. This is what the human body was built to do when food is not available. But here is the important thing. Switching to this fat-burning, ketone-producing state is not instant. The transition from using mostly glucose to using mostly fat and ketones happens gradually, and for most people eating a regular diet, it takes roughly 36 to 48 hours before that shift is deep and stable enough to really show up. Around the 40-hour mark is where most people land in that window. And that is exactly when the chemistry of your sweat starts to change. The 40-hour mark is not magic. It is simply the point at which the fat burning process has been running long and hard enough to start leaving traces outside your body. To understand why your sweat smells different, you need to understand one thing about the way fuel creates byproducts. When your body burns glucose, the process is clean and quiet. The main byproducts are water and carbon dioxide, and they leave the body without much fanfare. Your sweat during a fed state, when you are eating normally, is mostly water and electrolytes with a faint neutral smell that comes largely from bacteria living naturally on your skin. When the body switches to burning fat, the byproducts are different. The liver produces three types of ketone molecules. Two of them, let's just call them the working ketones, get picked up by your muscles and brain and used directly for energy. They do their jobs silently. The third one is called acetone. And acetone is different from the other two in one critical way. It is volatile. That means it does not stay in the blood. It evaporates and it finds its way out of the body through two main channels: through your lungs when you breathe and through your skin when you sweat. Acetone is the same chemical found in nail polish remover, which is exactly why so many people going through an extended fast describe a faint fruity smell or something that reminds them of chemicals or a light metallic edge to their breath and sweat. That is acetone. That is fat burning made detectable by your senses. Here is a simple way to picture it. Switching your body's fuel from glucose to fat is a bit like switching the type of fuel you burn in a fireplace. Oak and pine both burn, but they smell different. Not because one is wrong, just because the chemistry is different. Sweat is one of the ways your body vents what it is processing inside. And acetone is not the only thing contributing to the shift. When the body breaks down fat and also begins using small amounts of protein as part of its fuel mix, it creates additional compounds as byproducts. Some of these have their own faint smells, often described as slightly sour or with a subtle edge that is hard to name. This is completely normal in deeper fasting. There is also something else happening that most people never think about: the billions of bacteria that naturally live on your skin. Your skin's own living ecosystem are constantly feeding on whatever comes through your pores. When the chemistry of your sweat changes, these bacteria have to adapt. And as they adapt, the compounds they produce change too. So the smell you notice is not just coming from inside your body. It is the result of your internal chemistry shifting and the microscopic community on your skin responding to that shift in real time. This is not a flaw. It is biology doing what biology does. And it is happening because your body is working exactly as it should. Now, here is something that almost never comes up in conversations about fasting, and I think it is one of the most genuinely fascinating parts of this whole story. Your fat cells are not just a storage depot for energy. They are also a long-term holding area for certain chemicals that your body has been quietly accumulating over the course of your life. There is a category of environmental chemicals called persistent organic pollutants, sometimes referred to as POPs. These include certain old pesticides, industrial compounds, and other substances that have been in the environment for decades. The reason they are called persistent is because they are extremely resistant to breaking down. They stick around for a very long time, both in the environment and in the human body. What makes them relevant to this conversation is that they are lipophilic, which is just a scientific way of saying they bond very easily with fat. They are attracted to fatty tissue. So when these compounds enter your body through food, air, or water, your body responds by tucking them away inside fat cells, using the fat as a kind of protective cushion that keeps these chemicals away from more sensitive organs like the brain and liver. In that sense, your fat cells are doing you a quiet favor. They are acting as a containment system. But here is where fasting enters the picture. When you start burning fat in earnest, those stored compounds do not just disappear. They get released back into the bloodstream along with the fatty acids being mobilized for energy. Research published in peer-reviewed medical journals has confirmed that blood levels of these stored compounds can rise meaningfully when the body is actively breaking fat down at significant rates. Some of those released compounds, particularly the ones that are volatile, may find their way out through sweat. This is likely part of what gives fasting-related sweat that particular unfamiliar quality that is hard to put your finger on. It is not just ketones. It may also include trace amounts of compounds that have been sitting in fat storage for years, finally making their way through the system. Now, I want to be very straightforward with you here, because there is a lot of misleading content floating around about this topic in 2026. What is actually true is that fasting does release stored compounds from fat into the bloodstream, and the liver and kidneys then work to process and clear them from the body. That is a real biological process. And in that technical sense, there is something that qualifies as detoxification happening. What is not accurate is the popular claim that sweating during a fast is the primary way your body gets rid of these things. Sweat accounts for a very small fraction of the body's detoxification capacity. The overwhelming majority of that work happens in the liver, which neutralizes compounds, and the kidneys, which filter them out. Your pores are a minor channel, not the main one. There is also an important nuance that often gets left out. When fat is broken down rapidly and large amounts of stored compounds flood into the bloodstream faster than the liver can comfortably process, that is not automatically a good experience. The body handles this fine under normal circumstances with short to moderate fasts. But pushing into very extended fasting without proper hydration and electrolyte support means the liver and kidneys are working under strain. And that can sometimes translate into headaches, nausea, or a general feeling of being unwell, which people often misattribute to detoxification being successful when it is actually the body asking for more support to do its job properly. So when someone tells you that a long fast will flush all the toxins out of your body, the honest answer is it is more nuanced than that. And knowing the nuance matters. As fasting deepens past 36 or 40 hours, some people notice a different smell entering the picture. Something sharper, more chemical, unmistakably ammonia. Ammonia-scented sweat during an extended fast has a very specific cause, and once you understand it, it becomes a genuinely useful signal rather than something to panic about. Here is what is happening. Your body needs a constant supply of glucose for the brain, even when you are fasting. Fat can cover most of this through ketones, but there is still a baseline glucose requirement that ketones alone cannot fully meet, especially in the early and middle stages of transitioning to deep fat burning. To make up the difference, the body turns to a process called gluconeogenesis, which simply means making new glucose from non-carbohydrate sources. One of those sources is protein, specifically amino acids, which are the small individual building blocks that make up proteins in your muscles, organs, and other tissues. Breaking down amino acids releases energy and allows the liver to convert some of them into glucose. But this process also produces nitrogen as a waste product. Normally, the liver takes that nitrogen waste and converts it into something called urea, which is safe and easy to excrete through urine. But when protein breakdown is happening faster than the liver can process it, some of that nitrogen waste stays in the form of ammonia longer than it should, and a portion of it escapes through sweat. That is the source of the ammonia smell. Now, the question that matters is, does ammonia in your sweat during a fast mean you are losing muscle at an alarming rate? Not necessarily. And the distinction is important. A faint occasional ammonia note that comes and goes during an extended fast is fairly common. The body is using small amounts of protein as part of its fuel mixes throughout fasting, which is expected and manageable. The body also produces more growth hormone during fasting, which is a hormone that actively works to protect muscle tissue and make sure fat remains the primary fuel source. So a light background ammonia odor does not automatically mean muscle is being burned at a worrying rate. What does warrant attention is a strong, persistent ammonia smell that does not fade, especially if it is accompanied by unusual weakness, fatigue that feels deeper than normal, or muscle discomfort. This pattern suggests the balance has shifted more than it should. Often the reason is inadequate hydration, which concentrates nitrogen waste in sweat. Or it is a sign that electrolytes like sodium, potassium, and magnesium have dropped too low, which impairs the body's ability to handle nitrogen waste efficiently. Or it is simply a signal that the fast has gone further than this body at this time can sustain in a healthy way. The smell does not lie. It is just telling you something specific, and your job is to know what to listen for. A light fruity or chemical edge fat burning is running well. A faint sour edge mixed in deeper metabolic processes are active normal territory. A persistent sharp ammonia smell alongside physical symptoms. This is your body asking you to pay attention. And if that ammonia smell comes along with dizziness that will not pass, a heart rate that feels off, or confusion, those are clear signals to stop. Not signs of the fast getting harder, signs that the body needs to come out of it. Let's take a step back now, because I think when you look at everything we have covered, there is something genuinely worth pausing on. You have a signal system running continuously on the surface of your skin. A chemical reporting system that reflects in real time what is happening in your metabolism. Not approximately, not with a delay. Right now, as your body processes what it is processing, the evidence of that work is finding its way out through your pores. This is not a metaphor. This is physiology. And it is remarkable when you really think about it. We live in a time when you can buy devices to measure ketones in your breath strips, to detect them in your urine, continuous glucose monitors that track your blood sugar minute by minute. And all of that is genuinely useful. But there is also something powerful about understanding the signals your own body is already broadcasting without any equipment at all. When sweat smells faintly fruity after 40 hours, that is fat oxidation, the process of breaking fat down for fuel making itself known. When the smell shifts and deepens, it reflects which compounds are being released and in what proportions. When ammonia edges in, it tells you something specific about protein metabolism and whether the fast needs support or an exit. Even the sheer intensity of the smell tells you something about hydration, because dehydration concentrates everything the body is trying to move out. Hydration matters here in a very practical way. Water is not just for quenching thirst during a fast. It is the medium through which the body moves metabolic waste products. When you are well hydrated, ketones and other byproducts get processed and excreted smoothly. When you are not, they concentrate in your sweat and your urine, and everything from the smell to the physical discomfort becomes more pronounced. Electrolytes play the same quiet but essential role. Sodium, potassium, and magnesium are all involved in how efficiently the body processes nitrogen waste, how well the liver converts ammonia to urea, and how smoothly the kidneys handle everything that needs to be cleared. Losing these minerals during a long fast without replenishing them is one of the fastest ways to turn a well-intentioned experience into an unpleasant one. Not because fasting itself caused the problem, but because the body was not given what it needed to do the job properly. Understanding all of this changes the relationship you can have with fasting. Instead of white-knuckling through it and hoping for the best, you can actually read what is happening. You can pay attention to what your body is telling you and respond intelligently. That is a very different experience. We tend to think of fasting as something passive. You stop eating, you wait, time passes, and eventually something good happens. But that framing misses almost everything that is actually going on. 40 hours into a water fast, your body is not sitting still. It is running multiple complex metabolic processes simultaneously. It has redesigned its entire fuel system. It is producing a different class of energy molecules. It is releasing and processing compounds that have been stored in fat tissue for years. It is managing nitrogen waste, maintaining blood chemistry, protecting muscle, and doing all of this while keeping you functional and aware. And it is reporting on all of it in real time through the chemistry of your sweat. That smell you noticed is not a side effect. It is not something to be embarrassed about or anxious over. It is a data point. It is your body filing a report on what it is doing. And when you know how to read that report, fasting shifts from something you endure into something you can actually witness. You stop being a passenger in the process and start being someone who is paying attention. Someone who can hear what the body is saying and know what to do with it. If there is one thing to carry away from everything in this video, let it be this. Your body knows what to do. It has known how to fast, how to switch fuel sources, how to protect itself, and how to communicate its state for hundreds of thousands of years. Long before meal plans existed, long before the concept of intermittent fasting became a trending topic, long before any of us were here, the smell that surprised you is not confusion. It is competence. Your body working precisely the way it was always designed to work. Subscribe if you want more of this. Science that helps you understand what is actually happening inside you, explained in plain language without anything you have to take on faith. Your body has been speaking this whole time. We are just learning to listen.